So some of these problems that we've been working on are pretty interesting, like how we actually use this math in the real world. Sometimes it's harder to understand like the setup and where we get the formulas and all of that and the data than just to do the math if we're given the data. So this problem's kind of long. For some reason I felt like I should type the whole thing because I always do. But so here we go. An influenza epidemic spreads through a population rapidly at a rate that depends on two factors. The more people who have the flu, the more rapidly it spreads, and also the more uninfected people there are, the more rapidly it spreads. Okay, so these two factors make the logistic model a good one to study the spread of communicable diseases, and clearly there's a maximum value for the number of people infected, the entire population. Okay, so that's all information about this flu that we're talking about. Okay, for example, at time t=0, there is one person in a community of 1,000 people who has the flu. Okay, now that one is important because we're going to need that. So in the community, at most 1,000 people can have the flu. Okay, that's the carrying capacity then. The carrying capacity is going to be 1,000 people. That's as many as we can have that have the flu. Let's go ahead and write our formula over here. And we had that from the last video. C over 1 plus A e to the negative bx. Okay, so we know what C is. And eventually we're going to need to know A and B so that we can use this formula. Okay, researchers find that for this particular strain of flu, the logistic growth constant is B equals 0.6030. Okay, so they give us that information. They went and did the research, and that's what they found. Estimate the number of people in this community who will have the flu after 10 days. So eventually we want to find x equals 10. Well, we want to find f of x equals 10. Now, I just wrote that wrong. It's right the first time. Okay, x equals 10. And we want to find f of x. Okay, so that's the situation that we're in. We're going to predict how many people in this community will have this flu after a long period of time has passed. Okay, so they want us to do two things. All right. Let's see. We don't have A. That's the problem. We don't have A. So we have to find that. Now we're going to use this idea of one person. So we're going to say f of 0, no time has passed. We know the carrying capacity is 1,000. 1 plus A e to the, well, I can put in B, but it's all going to be 0 because x is 0, right? Okay. So I know that this equals 1. Because that's the one person that has the flu. This is the one person that has the flu. One flu person. Oh, not flu that way. Forget that either. Okay, so if you solve this equation for A, you're going to have 1,000. Oops. Now I'm going to erase that. Okay, we have 1,000 equals 1 plus A. That e to the 0 is just 1. Okay, so subtract the 1 and you get 999 equals A. Now we can set up our formula. Okay, so now we have like a real formula. F of x is going to equal 1,000 because we know the carrying capacity. We're going to have 1 plus 999 e to the negative 0.6030x. Okay, that's got the A, the B, the C. We've got that all filled in. Now, it says estimate the number of people who will have the flu after 10 days. So we're going by days. So we're going to say f of 10 is 1,000 over 1 plus 999 e to the negative 0.6030 times 10. Okay, so you could do some of the math by hand if you wanted to, but you can go to a calculator and put this all in. So we're going to take 1,000, divide it by, Now open a parenthesis. So you're going to need a parenthesis here. 1 plus 999 times, and then I need my e to some exponent. So again, it opens a parenthesis for me there. And I could do that math by hand, but I'll just put it in. Negative 0.603 times 10. And close the parenthesis, and what do I get? I get about 293.8507. But these are people we're talking about, so we're going to round to the nearest person. And so we're going to say about 294 people will have the flu after 10 days. Okay. And then the other thing, they say, predict how many people in this community will have had this flu after a long period of time. Well, we can't have more than 1,000 people. So after a long time, about 1,000 people may get the flu. There's probably some healthy person that's not going to get the flu. Okay, so that's what we're looking at though.